All right, let's talk about adding vectors using the sine and cosine laws. Your first step, whenever you want to use the sine or cosine laws, which hopefully you've learned about in math. If not, they're on your data pages. Please peruse it and ask me if you need help with that. They're not terrible. The hard part is drawing the triangle, and that's how you have to start. So your first step is draw your first vector, and it doesn't matter which one you decide to go first with. I may as well just do this one. So I'm going to start with 9 meters, 35 degrees northeast. So here we are. Here's my vector. It is 35 degrees north of east. And then I'm going to draw my next line. It's going to be 7 meters, 25 degrees south of east. Now, my resultant vector, and the one I'm looking for to try and get the angle and everything, is this one from my first tail to my last tip. You can imagine, like, if I walked 9 meters in this direction and 7 meters in that direction and ended up here, here is kind of how far I am from where I started in a straight line. And if I can find this angle, that's my direction I am from where I started. So now we just got to figure out really this angle. Once we find this angle, we are good to go. But that might not be the easiest. But it might not be the hardest. So let's take a look here. We know this angle is 25. If this vector here makes an angle of 35 with the horizontal, this will also be 35 because this is the angle it makes with the horizontal as well. Anytime you got something that looks like an N or a Z and these two lines are parallel, then your interior angles are the same. It's called alternate interior angles. So yeah, I happen to know this angle is 35, and I know this angle is 25. And I also know there are 180 degrees if you turn around. So this angle plus this angle plus this angle should add up to 180. 180 minus 35, well, 35 plus 25 is 60. 180 minus 60 is 120. So I know that angle is 120. At this point, I can use the cosine law to find this side. Cosine law is just like Pythagoras. In fact, Pythagoras is a simpler form of it. It's c squared equals a squared plus b squared minus 2ab cosine big C, where you've got a triangle with A, B, and C, and the opposite sides are related to the angles are related to the side opposite them. So this C would be, let's call this C right here. So we want to find that C. We know the angle opposite it, and we know the two other sides, which is all we need. Anytime you got a side, angle, side sandwich like this, cosine law is your friend. So we will just plug her in. It's equal to 9 squared plus 7 squared minus 2 times 9 times 9 times 7 times cos of 120. And if we take the square root of that, that will be our displacement from where we started. So I'm going to cheat and look at my answer key, which happens to be 4.3 meters. Or no, sorry, 13.9 meters. All right, now we've got this side. We also want this bloody angle here, which is going to be slightly annoying. But to do that, we can use our sine law, which says that sine of some angle divided by the side opposite it is equal to the sine of any other angle. In this case, I'm going to go with C, divided by the length of the side opposite it. The ratio of sine of an angle to the side opposite is the same for every angle and opposite side in the triangle, which is kind of cool, kind of weird. So to find this angle down here, I'm going to figure out what this angle is and then just do 35 minus that. So to find this angle, I'm going to do this whole business. I happen to know an angle and a side opposite it. So I'm going to say, hey, sine 120 divided by this side here, which is 13.9. That ratio of sine of an angle divided by length of the side opposite is the same for all sides. So I'm going to say that's equal to sine, I'm going to call this, I don't know, theta 1 divided by 7. So theta 1, or I'm just going to say sine of theta 1 is just equal to 7 times sine 120 over 13.9, and so that'll give me the ratio of sides, but that's not what I want. I want theta, so to get that, I'm going to have to inverse sine both sides. If I inverse sine both sides, I'm going to find out that my theta 1 is equal to the inverse sine of 7 times sine 120 all over 13.9. So you go plug all that garbage into your calculator, you will get 25.8 degrees. Now, if we know this distance is 25.8 degrees, and this full angle is 35, so if we want just this guy, we can just do 35 minus 25.8 and get 9.2 degrees, just like we did when we did it with components. So our final answer is this guy, and this is 9.2 degrees. Notice it is north of the east line. So our final answer, 13.9 meters at 9.2 degrees north of east. And that's another way you can solve this. Yeah, in this case, I don't know if it's any easier, but once you practice it a bunch, there are definitely questions where sine and cosine law do make your life easier rather than harder. Anyway, thank you for listening. Hope it helped.